Okay. Hello dear students. Today we are here for the fourth lecture of this subject thermodynamics. Already we have completed 3 lectures during which we have seen some basic concepts and definitions which are required for the thermodynamics. In last lecture we have seen what is property, types of properties, what is state, what is process, and different types of processes. So today we are going to see what is a quasi-static process, what is the equilibrium state, what is the temperature and zeroth law, and explanation of that zeroth law. Okay, quasi-static process. So quasi-static, the process can be restrained or unrestrained. We need a restrained processes in practice. The processes can be restrained or unrestrained. We need a restrained process in practice. A quasi-static process is one in which the deviation from thermodynamic equilibrium is infinitesimal. So that means the change in properties or the deviation of the system from one state to another state is very small. So that means intermediate states. So that means we know that in the last lecture the process is from state 1 to 2. So and 1 is in equilibrium state and 2 is also equilibrium state, but we don't know what is about the intermediate points on that process or in between that two states. If they are finite or determined, then we say that that is a quasi-static process. So that means deviation from one state to another state is infinitesimal. All states of the system passes through our equilibrium states. So now here you see a gas is enclosed in a cylinder and piston is there over which a small vents are there. Suppose initially a piston and gas is enclosed in piston and cylinder arrangement and we kept a 1 kg of weight on the piston, and if you remove that 1 kg of one weight, suddenly the piston will move from 1 to final state directly. So that means only we can know initial state and final state. We don't know what happens in between these two states because suddenly the piston will move from state 1 to 2. But instead of that, if we divide that 1 kg of weight in number of small weights, and if we remove, suppose initially piston is at particular position and on that piston a number of pieces of weights are there. Initially we can locate the state and after that one by one we are going to remove the pieces of the weights. So every time we are going to determine the position of the state. So that means there is a small deviation in the position of the piston. So that means the states are determined. So after the removal of all the pieces, the piston will move its end state, and if you join the locus of each and every states, so that is nothing but the process, and such a processes are the quasi-static process. Quasi-static processes are the almost very slow processes. Okay. Now quasi-static process. If we remove the weights slowly, just I explained to you what happens during the quasi-static process. If we remove the weights slowly, one by one, the pressure of the gas will displace the piston gradually. it is quasi-static. So that means it is a slow process. On the other hand, if we remove all the weights at once, the piston will be kicked off by the gas pressure. This is unrestrained expansion. But we don't consider that the work is done because it is not in a sustained manner. In both cases, the system have undergone a change of state. In both cases, suddenly remove of the weight or one by one we are going to remove. In both cases, the system have undergone a change of state. Another example, if a person clamps down, this is one good example of this quasi-static process. If a person clamps down a ladder from roof to ground, it is a quasi-static process. On the other hand, if he jumps, then it is not a quasi-static process. Now equilibrium state. So in thermodynamics, so every time the word comes, equilibrium, equilibrium, equilibrium. So what do you mean by equilibrium? So there is no any change in system whenever there is a change in outside the system or in surrounding. According to change in surrounding, if there is no change in this system itself, then we call it as the system is in equilibrium state. A system is said to be in an equilibrium state if its properties will not change without some perceptible effect in the surroundings. Equilibrium generally requires all properties to be uniform throughout the system. So that means all the properties which are within that system are uniform throughout the system. There is no any change as per the change in the surrounding. There are mechanical, thermal, phase and chemical equilibrium. We say thermodynamic system is in equilibrium when it is simultaneously equilibrium in mechanical, thermal, phase and chemical equilibrium. Now, what is about this chemical equilibrium? So when we say the system is in mechanical equilibrium, when there is no any unbalanced force within the system or system and surrounding, when there is no change in its phase, when there is a change in surrounding, then there is no any chemical reaction occurring within the system, then we call it as in chemical equilibrium. When there is no any temperature difference within the system itself or within the system and surrounding, and these are the different thermal, mechanical, phase and chemical equilibrium. When the system is in equilibrium in all this, then we say that this is thermodynamic system is in equilibrium. Now equilibrium state, nature has preferred way of directing changes. Nature has a preferred way of directing changes. For example, water flows from higher to lower level. Water flows from higher to lower level. Electricity flows from higher potential to lower one. Heat flows from a body at higher temperature to the one at lower temperature. Momentum transfer occurs from a point of higher pressure to a lower one. Mass transfer occurs from higher concentration to lower. So these are some natural processes which are happening in the nature. Now types of I have explained the types of the equilibrium when we say that thermodynamic system is in equilibrium, when the system is in thermal equilibrium, mechanical equilibrium and chemical equilibrium, then we say that the system is in equilibrium. Between the system and surrounding, if there is no difference in pressure, mechanical equilibrium, potential, electrical equilibrium, concentration of specific species equilibrium, temperature, thermal equilibrium, no interactions between them occur, they are said to be in equilibrium. Thermodynamic equilibrium implies all those together. So that means when the system is in all these equilibriums, then and then only thermodynamic system is in equilibrium. A system in thermodynamic equilibrium does not deliver anything. Now, temperature and zeroth law of thermodynamics. Temperature is a property of system. Already we have seen that temperature is one of the property of the thermodynamic system, which determines the degree of hotness. Obviously, it is a relative term. Example, a hot cup of coffee is at higher temperature than a block ice. On the other hand, ice is hotter than liquid hydrogen. Thermodynamic temperature scale is under evaluation, what we have now in empirical scale. So this is the, or now we are going to see a zeroth law of thermodynamics, which is basis of this temperature measurement. This is one of the, temperature is one of the property and it is a relative term, just now we have seen. Now we are going to see the laws of thermodynamics. The laws of thermodynamics are very important as far as the thermodynamics is concerned. In all, there are 4 laws. First law, second law, third law and zeroth law. Now, why it is not given the name fourth law? So, why it is a zeroth law? So, all first and second law come in picture, and then it is observed that there is one more law, but that law is the basis of these laws. So, that's why it is given a name, a zeroth law. So, what is zeroth law? Zeroth law is a basis which is used for the temperature measurement. So what is the statement of the zeroth law? Two systems are said to be equal in temperature. Two systems are said to be equal in temperature when there is no change in their respective observable properties when they are brought together. In other words, when two systems are at the same temperature, they are in thermal equilibrium. Already we have seen. They will not exchange heat. Note, they need not be in thermodynamic equilibrium. They are in thermal equilibrium. But we know that the system is in thermal equilibrium when it is simultaneously in chemical, thermal and chemical equilibrium and mechanical equilibrium. So by equilibrium in thermal, we cannot say that system is in thermal equilibrium or thermodynamic equilibrium. Now this is zero explanation of the zeroth law. If two systems, in all there are 3 systems A, B, C. If two systems, say A and B, are in thermal equilibrium with third system, say C, separately, that is A and C are in thermal equilibrium, B and C are in thermal equilibrium, then they are in thermal equilibrium with each other. That is A and B will be in thermal equilibrium. So that means 3 bodies are there. Now explanation of zeroth law. Let us say TA, TB are the temperatures of system A and B, and TC are the temperatures of the A, B and C respectively. A and C are in thermal equilibrium, therefore TA is equal to TC. B and C are in thermal equilibrium, TB is equal to TC. Consequently of the zeroth law, A and B will also be in thermal equilibrium, TA is equal to TB. Looks very logical. All temperature measurements are based on this law. As already I told you that the zeroth law is the basis of the temperature measurement. So this is something about this law of the zeroth law of thermodynamics.